In this video we're going to be talking about dividing fractions and also some other examples of division. So our first and foremost is dividing fractions. Say we have a proper or improper fraction a over b divided by c over d. It's going to be one example we cover today. We're also going to cover two other examples. I've placed the other two on the screen for you. This middle example here is a whole number divided by a fraction, be it proper or improper, and then the last one would be a proper or improper fraction divided by a whole number. So there's three different scenarios that we will encounter. We're going to deal with this first one first. At the beginning here, I want to cover this in a generic method. So using letters, a over b divided by c over d is simply a over b, the first fraction, multiplied by the reciprocal of the second fraction. You might want to press pause and put the same notation in here as we go through. Again, I have to stress that you should be taking active notes as you watch these videos. So d over c is the reciprocal of c over d. That's about it. From here on, all you really need is the multiplication video. To divide a fraction by a fraction, you multiply by its reciprocal. Go ahead and press pause and copy this sentence down into your notes. To divide a fraction, we're talking a over b, to divide this fraction by a fraction, you multiply by the reciprocal. Let's go ahead and try to put this into action. In order to divide 2/3 divided by 7/5, we're going to write our original fraction, 2/3, and rewrite it as 5/7. Now I'm going to caution you, don't skimp, don't just scribble it here and cross this out. Physically rewrite a separate problem. Now we're just going to take a look. Is there any reducing we could do here, here, or along the diagonals? If not, then all we're going to do from multiplying knowledge is multiply straight across the top. 2 times 5 is 10. 3 times 7 is 21. As long as we have taken care of any reducing prior to multiplying, we should have a reduced fraction, but I always check my fraction here to make sure that it is not reducible or simplifiable. Do 10 and 21 have any factors in common? Nope. So we're all set. That's our final answer. 2/3 divided by 7/5 is equal to 10/21. Let's try another one. Okay, so we have 6/9 divided by 12/18. First thing I'm going to do is rewrite 6/9 times the reciprocal of 12/18, which is 18/12. Now, I have all types of great cancellation. I could cancel 6/9 and make that 2/3. So I'm just going to write that right here. I can make that 2/3. I can make 18/12. Those both have factors of 6, so that would be 3/2. Then this cancels, and I'm down to just 1. Or I could have said, hey, this is 1/2. 9 goes into 18 2 times, that's 1/2, and this cancels out to be 1, and 1 times 1 is 1. Now that's a pretty hearty example of how a lot of things just start canceling everywhere. Let's try again. 6/4 divided by 27/4. First thing I'm going to do, write my first fraction, change it to multiplication, rewrite it in terms of the reciprocal, and now we have a multiplication problem. 4 is its own factor. 4 goes into 4 one time each, so there's a 1 and a 1. And then 6 and 27, greatest common factor we have there is 3. 6 divided by 3 is 2. 27 divided by 3 is 9. So now we have 2 and 1 on the top and 1 and 9 on the bottom, which leaves us with 2/9 as a final answer. That's, as many examples I think you should need. If you need more, just go back to the multiplication video. That'll help you with the cancellation piece. Other than that, I think we've taken care of the division. Now what happens when whole numbers come into the situation? So we have the fraction 63/45, which is an improper fraction. It's irrelevant whether it's improper or proper, but we have a fraction divided by a whole number. The easiest thing you could do is recognize that 4 is the same as 4 over 1. This is 4 divided by 1 is 4. Now that I've added the 1, I've given myself two fractions. And I'm right back to where I started, where I have a fraction divided by a fraction. The rest of this is just as we were just doing. 63 over 45 times 1 over 4. Okay. Now, if along the way you want to reduce this fraction over and write the 63rd 45ths as a reduced version as you rewrite it, it might be a good idea. Depends on your comfort level. The number of steps you take depends on your comfort level. Are you still taking notes with me? What goes into 63 and 45? Biggest factor we can think of, right? Our GCF is 9. 63 divided by 9 is 7. 45 divided by 9 is 5. And now I look, anybody else? Can I reduce this any further on the diagonals? Nope. 7 times 1 is 7. 5 times 4 is 20. And I'm left with 7/20 as a final answer. That takes care of the fraction divided by a whole number. What about a whole number divided by a fraction? So now we have our whole number 3 divided by 48/64. What's my recommendation? But to re-express 3 in terms of a fraction. 3 divided by 1 is 3, so I just put the 1 under 3. The rest is pretty much a piece of cake. 3 divided by 1 times 64 over 48, right? My reciprocal. I want to keep driving home that vocabulary word. Now, greatest common factor might be challenging here, but what's a large factor that goes into 64 and 48? 8 goes into both of these. 8 goes into 64 8 times, and 8 goes into 48 6 times. And now I see, oh, 8 and 6 also have factors in common, 2. So 8 divided by 2 is 4, and 6 divided by 2 is 3. Now we have, on our top part, we have 3 and 4, and on the bottom we have 3 and 1. But hey, look at this. The 3's cancel out. 3 divided by 3 is 1. So now across the top I have 4 times 1 is 4, and 1 times 1 is 1. So that's just simply 4 for a final answer. If you left it as 4 over 1, that's not simplified. The point here is to find the product and simplify. Let me correct that last statement. Find the quotient. We're doing division. My apologies. We're going to find the quotient and then simplify. So 4 over 1 is the quotient of 3 divided by 48/64, but the simplified answer is just 4. On a side note, I said that greatest common factor for 64 and 48 was tough. First we divided by 8, then we divided by 2. You take those two factors and multiply. 16 was our GCF. 16 goes into 64 4 times, and 16 goes into 48 3 times. Maybe next time you see him you might remember that. So that brings us pretty much full circle. I believe that we've wrapped up. We've covered an example of fraction divided by a fraction, a whole number divided by a fraction, and a fraction divided by a whole number. I did these last two in reverse order of the way I introduced them, but we have an example of each. So now it is up to you to practice, practice, practice. Okay, keep up the good work. This will pay off. Fractions are going to keep coming up year after year after year, and your ability to deal with them nicely and easily and efficiently is critical. See you next time.